What's up, everybody? It's Dan from SageMathTutoring.com, soon to be SageMathTestPrep.com, actually. Probably be making that change pretty soon, but here we have another SAT Math video where I cover some of the kinds of problems that you might have to face on the SAT Math section, and as usual, we're just going to dive right into it. So looking at the first one, John runs at different speeds as part of his training program. The graph shows his target heart rate at different times during the workout. At which interval is the target heart rate strictly increasing, then strictly decreasing? So strictly increasing and then strictly decreasing, so that should be sort of like an up-down kind of thing. I definitely see an up-down thing here, right? So let's see, 40 to 60 is where this up-down thing goes on. And that is answer choice B. All right, if y equals kx, where k is a constant, y equals 24, where when x equals 6, what's the value of y when x equals 5? So this is definitely a direct proportion problem. And really, it's really all about this formula. If it was an indirect like variation problem, then it would be something like that, where the k is on top, so that's a k right there. And you'd have to kind of use that one if it was indirect, but this one happens to be direct. And the key with these kinds of problems is to figure out what k is first and then take things from there. And the way that you find k is by using the clues that they give you. So they say y equals 24 when x is 6. That's the clue. So in other words, 24 equals k times 6. And then k, therefore, equals 4. And we'll get rid of this guy. So we now know what k is, which basically means that we can rewrite this equation as y equals 4x. Because now we know for sure that k is equal to 4. So really, we could rewrite this as y equals 4x. And then we use this new and improved equation to figure out what y is when x is 5. So solving for y, substituting 5 in for x, y clearly equals 20. That is the answer. Moving on. All right, in the figure above, lines L and M are parallel and lines S and T are parallel. So everything's, the things that look parallel are parallel. If the measure of angle 1 is 35, what's the measure of angle 2? All right, so as soon as you write like parallel lines, like let's take L and M as an example, and we'll look at T as the transversal, just taking into account this situation over here. Not this part, but this part only. Notice how you formed 8 angles. There's this angle, this angle, this angle, this angle, this angle, and so on, right? And some of the angles are small, which I'll denote in green, and other ones are big, which I will denote in red. Now, it is the case in this whole section that all the small angles equal each other, and it is the case in this section that all the big angles equal each other. So that's this section. Another way of looking at it is that, yeah, L and M are parallel, and this is also a transversal as well. So all the small angles equal each other, and all the big angles equal each other. Now, one thing to take into account is that S and T are parallel, and line L is a transversal, in which case all the small angles are equal and all the big angles are equal. And the same applies to this scenario, where all the small angles are equal and all the big angles are equal. So I'm going to label everything across the board that way. So the small angles will be in green, the big angles will be in red. Now, for the record, when you're doing the SAT, you don't necessarily need to do all this. Part of the purpose of this video is to just kind of show the thought process behind everything, but the time it takes to actually do the problem should be much less than what I'm doing right now. So nonetheless, if the measure of angle 1 is 35, well, that's right here. You might as well label it, right? And by the way, if that's 35, then of course we know that all of the angles in green are 35, right? Including that one. I'm just going to pause it there for a second. So what is the measure of angle 2? Well, angle 2 is right here. Angle 2 is clearly a linear pair with this small angle, and these angles are supplementary. So that's going to be 145. supplementary, meaning they add up to 180. In other words, 35 plus whatever this is. We could call it x. 35 plus x equals 180. X clearly must therefore equal 145. Moving on. Okay, if 16 plus 4x is 10 more than 14, what's the value of 8x? You might want to just write that, right? So 16 plus 4x. The word is means equals. So that's going to be equals. And 10 more than 14, well, that's like 14. And then 10 more than that, also known as plus 10. They ask for 8x. Now, obviously, we could solve for x, right? And then just multiply it by 8. That's totally fine. And to be honest, a first step would be to add that 14 plus 10. So that's 24. 16 plus 4x. That's totally fine. Now, I'm going to subtract 16 from both sides. And I'm going to get 8, right? And they want 8x. Now, 8x is twice that, so I'm just going to multiply both sides by 2, kind of saving time that way. And then 8x we have on the left, and that clearly equals 16. Notice how they're not asking for x, they're asking for 8x, so that is the answer. Which of the following graphs best shows a strong negative association between D and T? Well, D is the x-axis, T is the y-axis. Negative association means it goes down from left to right, and clearly that takes place with D, and that is the answer. This one's a positive association. This one is kind of like no association, and this one is no association. All right, a hospital stores one type of medicine in a 2 decagram containers based on the information given in the box above. How many 1 milligram doses are there in one 2 decagram container? Well, the first thing that sort of pops out at me is the fact that, 1 decagram has 10 grams. So immediately my mind is going into, if we have a 2 decagram container, well, that's going to be 2 times this, right? And that's going to give me 20 grams. So I could say a 2 dec container gives us 20 grams. And so we want to know how many 1 milligram doses are there in one of these, in one 2 decagram container, also known as one of these. How many 1 milligram doses are inside this? Well, apparently there's 1,000 milligrams in 1 gram. We have 20 grams in one of these. So it's going to be 20 times 1,000, right? So that is going to be, 20,000 milligrams. So that is the answer to that one. The number of rooftops with solar panel installations in 5 cities is shown in the graph above. The total number of installations is 27,500. What is an appropriate label for the vertical axis of the graph? Well, obviously the number, like each of these are the cities, right? So city A, city B, city C. And the total number of installations is 27,500. Now clearly this only goes from 0 to 9, so this is not like a literal numerical interpretation of the reality of what's happening here. It might be like 1,000, 2,000, 3,000 for all we know. We're not really sure just yet, but the bottom line is, it's going to be 9 times like some number x, right? It's going to be 9 times some number x because that's the amount of rooftop solar panel installations in this city. It's really 9 times some number x. And then it's going to be that added to 5 times whatever that number is, 5x, right? 5 times some number x. And then it's going to be in city C, it's 6, so it's going to be plus 6x. City D, it's 4, so that's going to be 4x. City E looks like that's 3.5, so that's kind of annoying, but we're going to do 3.5x. And that probably explains the 500 part. And then that's going to be set equal to 27,500. All right. And then, of course, you combine like terms. 9 plus 5 is 14, plus 6 is 20, plus 4 is 24, plus 3.5 is 27.5x, and that gives you 27,500, which makes total sense. Now, I know this might be weird because, well, actually, no, this is the calculator section. I should have mentioned that in the beginning. This is the calculator section. So, yeah, all you have to do is divide both sides by 27.5 in the calculator. You could also realize that this is some number that's going to move the decimal place over 1, 2, 3 times. So x should be 1,000. But nonetheless, calculator is totally fine. So we have x equal 1,000. So in other words, when it came to, like, let's just analyze this one. That was the first city, right? City A was all the way up to 9, and that corresponded with this thing called 9x. So this doesn't literally, like, City A does not literally have 9 rooftop solar panel installations in it. City A has 9 times x, also known as 9,000 rooftop solar panel installations within it. So this y-axis, also known as the vertical axis, is in thousands. All right, so that's how you do that. For what value of n is absolute value of n minus 1 plus 1 equal to 0? So I would go ahead and just like set that up. So it's like that. I've set it up equal to 0 and be like, I don't know, let me find out. You know, solve for n. Subtracting 1 from both sides would give me a negative number. And this is, as I suspected, it's kind of a little bit of a trap. You would just pause here because, you know, under normal circumstances, there would be a way to solve this. You'd like split it into 2 separate equations and so on. But it's really this moment that you just want to stop and just be like, all right, is it ever the case that the absolute value of something, it doesn't even matter what it is, gives you a negative number? No. Whenever you have some number in here, whether it's positive or negative or whatever, it always you know, the absolute value symbols always turn it into like a positive number. So it's impossible to have the absolute value of something and get a negative number, so therefore D. Okay, the equation, so that's a linear equation, maybe just making a mental note of that. The speed of a sound wave in air depends on the air temperature. The formula above shows the relationship between A, the speed of the sound wave, in feet per second. Okay, so just A is the speed of the sound wave, just remember that, feet per second. T is the air temperature. All right, which of the following express the air temperature in terms of the speed of a sound wave? Yeah, in other words, solve for T, basically, right? Well, I'll rewrite this equation. Looks like it's A equals 1052 plus 1.08 T. And yeah, solving for T, let's at least get this term by itself. We're going to subtract 1052 from both sides. All right. And that's going to give you 1.08 T. And then in order to get T by itself, all you have to do is divide both sides by 1.08. I'm going to kind of leave out that written step, but nonetheless we have this, and then it's all over 1.08, and that's the answer, which is given right here. I'm just going to be super careful. Yes, it's definitely A. All right, which of the following air temperatures will the speed of a sound wave be closest to 1,000 feet per second? So once again, the speed of the sound wave is A. So you want to just force A to be 1,000, right? And then solve for T. So, you know, what's actually cool is you could use this original, but you know what? You could totally use this one because if you just plug in 1,000 here, that's going to give you the answer. That might even be a smarter way. So it's like 1,000 minus 1052, also known as 1052, all over 1.08. And basically that's the answer. I'm going to use my calculator right now. Yeah, so that gives me, let's see, negative 48.148, also known as negative 48.15, we could say. And that is this one. Okay, notice how they are being tricky. They're giving you negative 49 as well. So they're expecting you to recognize that the number that you just got in your calculator, which is negative 48.1481, blah, 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 that really, because of this tenths digit, it could be rounded to negative 48, right? So that's the answer. I want to be careful there. Which of the following numbers is not a solution of the inequality this? Well, what I would do is I would solve this inequality first, right? And in a way, you kind of treat it like a normal equation. I can already see, to illustrate a point, I'm going to keep the x's on the left, okay? So let's subtract 4x from both sides, right? And we end up with negative x, minus 5 is greater than or equal to negative 3. And then adding 5 to both sides would give us negative x is greater than or equal to positive 2. Now, I kind of committed to having the x on the left-hand side because I could have solved it with the x on the right-hand side, but I want to illustrate the following point. We are about to, in a way, solve for x right now. And but there's a negative 1 in front of it, right? So we want to get rid of that negative 1. The way that we're going to do that is divide both sides by negative 1. Now, many of you at home probably remember, but just in case you don't, I do want to remind you, anytime you divide or multiply both sides of an inequality by a negative number, you have to, these cancel, that's the whole point, right? You have to change the direction of the inequality, so it becomes that. All right. Now, in the final answer, it's always kind of nice to have the x on the left anyway for numerous reasons, but one reason is because, it's like x is less than negative 2. Like, you can clearly see what's going on, and you could treat this as like an arrow if it was graphed on a number line. So, for example, if we had a number line and you had negative 2 right there, it would be on negative 2, and we know that the arrow would be pointing to the left because this arrow is pointing to the left. So anytime you have x on the left-hand side in your final answer, you can almost treat the inequality symbol as though it's the arrow. All right, so it's going to the left. It's a nice little trick of the trade for you. So we want to know which is not a solution. Well, is negative 1 a solution? Absolutely not. That's the answer right there, because negative 1 is right here. Right? That is not a solution because it's right here, and all of our solutions are from negative 2 downward. Based on the histogram above of the following, which is the closest to the average arithmetic mean number of seeds per apple. Okay, so number of seeds are here. Some apples have 3 seeds, none of them have 4, some have 5, 6. And basically the way that this works, number of apples. So basically 2 apples have 3 seeds, 4 apples have 5, 1 has 6, 2 has 7, none have 8, and 3 has 9. So if you want to do the average, well, we all know the average equals the sum of numbers. I'll just put sum over, I don't know how many numbers you have, right? So bottom line is with this one, we need to do the proper sum, obviously. I'm going to first focus on how many apples we have, though. It even tells you there's 12, right? Another way of having figured that out was you could just be like 2 plus 4, which is 6, plus 1, which is 7, plus 2, which is 9, plus 3, which is 12. But they actually tell you that it's 12, so I'm going to write that in the denominator. I know that it's going to be basically the sum of all the seeds divided by 12. So the question is, how many seeds are there? Well, there's 3 times 2 seeds, right? Because there's 3 seeds in 2 apples, right? So I will say 3 times 2. And we're going to be adding that to 5 times 4, right? Because there's 5 seeds and 4 apples. So that's going to be 5 times 4. And we're going to be adding that to 6 times 1. I'm just going to write 6 if you guys are cool with that. I'll still wrap it in parentheses, though. Let's see. This one's going to be 7 times 2 for the exact same reason. So that's going to be 7 times 2. And this one's going to be 9 times 3. So it's plus 9 times 3. And this is all stuff that you could even plug into your like graphing calculator just in general. Bottom line is, with this, PEMDAS says that multiplication should take place first. So even if you weren't to use a calculator, it would be 6 plus 20 plus 6 plus 14 plus 27 all over 12. Now, I'm going to just use my calculator right now. I'm going to add all this, and I'm going to divide by 12, and I'm going to get, so I got 6.083 repeating. And the good news is that they say which is closest to the average. Well, this clearly rounds to 6, so that's the answer. All right, moving on. All right, group of 10th grade students responded to a survey that asked which math course they were currently enrolled in. The survey data were broken down as shown in the table above. Which of the following categories accounts for approximately 19%? 19% of all survey respondents. Well, all survey respondents would be 310, right? These are all the females. Apparently there are 150 of them. These were all the males. Apparently there are 160 of them. And then there's 310, which is, all survey respondents. So we want to know which one of them is 19% of 310. All right, that's essentially what's being asked, which of these categories. And you could even kind of look at the answer choices to get a sense of, like, the fact that they're really just focusing on which of these little squares or rectangles is such that it's close to 19% of 310. Well, I think the obvious thing to do is to find 19% of 310. And the way that I'm going to do that is to convert 19% into 0.19. I'm going to convert the word of into multiplication. I'll use an asterisk, and 310 is just 310. And that's going to give you 58.9, which really rounds up to 59. So we have a 59 right there. And that would be males taking geometry. So this is the answer, and we are done. All right, table above lists the length to the nearest inch of a random sample of 21 brown bullhead fish. The outlier measurement of 24 inches, this one right here, is an error. It's an outlier, it's an error. Of the mean, median, and range of the values listed, which will change the most if the 24-inch measurement is removed from the data? So basically, that would change the range the most, because the range used to be from 24 to 8, so it's like 24 minus 8, that is 16. So the range used to be 16 when we had this here, but then all of a sudden it turned into a range of 8 because 16 minus 8 is 8. So that is a big change, right? So it's really the range that's most affected. Now you might be wondering, okay, well, what about the median? Well, the median, let's see, there's 3 by 1, 2, 3, 4, 5, 6, 7, and they are all in order. So that's going to be, I guess, the 11th one, right? So this is the median. So the median actually doesn't change. The median remains 12, because in this scenario where 24 is the highest one, 12 is the median. And then when you take 24 away, you're going to have an even amount of numbers, and then you just take the average of these two. And the average of 12 and 12 is 12. So the median literally doesn't change. You could also go through the motions to find the average of everything, and then divide by 21 and compare the averages. But I think intuitively a lot of you can see that when you add all of these and then divide by 21, the result that you get is it's gonna be a little bit higher than the average that you would get if you took 24 out of the picture and just added all this stuff and then divided by 20. I think intuitively you can see that. The 24 does bump the average up a little bit, but it doesn't bump it up 8 points, which is the disparity here when it comes to the change in range. So that's how you would navigate that one. All right, the graph above displays the total cost C in dollars of renting a boat for H hours, right? So first thing I see is that at 0 hours, there's like a 5 right here, total cost, $5. So it sounds like you pay the boat rental place like $5 like right away, you know, and then however long you're out there with the boat, well, you have to pay even more, right? Okay, what does the C-intercept represent? Okay, so that's literally what I just said. Okay, I'm kind of used to these, so I know that, like, my eyes are immediately drawn to this Y-intercept, and I'm thinking, like, okay, well, at 0 hours, there's still a cost associated, so that's interesting. So does the C-intercept represent, it's the initial cost of renting the boat, yes, initial cost of renting the boat. All right, which of the following represents the relationship between H and C? Well, first of all, this is a y-intercept of 5, so I am only interested in these two because these are linear equations and they have a y-intercept of 5. The question is, what is the slope of this line? Now, you want to be careful because you have, you know, all the way up to 6 here and you only have up to 1 here. So this is really just a matter of getting a sense of, you know, what happened, let's say, between this point and this point. Now, you could do the slope formula if need be, or you could just eyeball it and ask yourself, well, what's the rise and what's the run? So it goes from 5 to 8, it goes up 5, well, pardon me, it goes up 3, right, from 5 to 8, and then it goes over, and you have to be careful with this, it goes over 1, right? Up 3, over 1, because that's a 1 right there. And what do we call that slope? Up 3, over 1, also known as rise over run. And, you know, that's really just 3. So this is the answer. That's the slope because, of course, 3h. That's the term that has the slope in it. Moving on. The complete graph of the function f is shown in the xy plane above. For what value of x is the value of f of x at its minimum? So f of x, it's helpful sometimes to think of f of x as meaning like the y value of any given point, or the y-coordinate, you know, or the height of the graph. You could think of f of x as the height of the graph, depending on like what x value you're analyzing. Like, for example, the height of the graph here, when x is 3, is all the way up here. What's that? 1, 2, 3, 4, 5, right? So when x is 3, f of x is equal to 5, right? But we want to know, where is f of x at its minimum? Well, that's right here. Clearly, it's the lowest part of the graph. It's right here at -2 as, you know, a y coordinate. But the question is, for what value of x, you know, is it associated with that? And that would be -1, -2, -3. So -3. Okay, in the xy plane, if 0, 0 is the solution to the system of inequalities above, which of the following relationships between a and b must be true? Well, I know you could get bogged down fairly easily with this one, being like, okay, solution to the system of inequalities above. Well, it's like, what the heck does that mean? And maybe you vaguely remember, like, having to graph, you know, the inequalities. Maybe one of them's a dotted line, and then another one is like a solid line, and you're shading above this one, and yet you're shading, like, you know, we could say below this one, and, you know, the solution set ends up being here. You know, it's this whole thing that maybe other SAT questions might sort of demand that you like go there with the graph. However, this one, believe it or not, doesn't require that so much, because they actually tell you like 0, 0 is in the solution set. So in other words, another way of saying that 0, 0 is in the solution to the system of inequalities. That basically means that you could plug 0 in for x into either of these inequalities. You could plug 0 in for y into either of these inequalities, and it would result in a true statement. All right? And let's analyze both situations. So we're going to plug 0 in for x and 0 in for y, and let's see what happens with this top one. It's going to become -0 plus a, and therefore we can see very clearly that a is greater than 0, or we could also think of it as 0 is less than a. Similarly over here, we're going to plug 0 in for both x and y, and we soon realize that 0 is greater than b. Another way of saying that is b is less than 0. So you have a is greater than 0, you have b is less than 0. So in other words, you got 0 kind of hanging out over here, and you've got a, which is totally greater than 0, based off of this information, and you've got b, which is totally less than 0, based off of this information, right? Also known as negative, also known as positive, right? So what do we know for sure? Well, this says a is greater than b. Well, is that true? Well, absolutely, right? If a is a positive number greater than 0, it is, in a sense, by definition, greater than b, which is clearly a negative number, so that's the answer. The food truck sells salads for that, each drinks for that. Food truck's revenue from selling a total of 209 salads and drinks in one day was that. How many salads were sold that day? Okay, so classic system of equations problem, and yeah, so we're going to say the following. I'm going to write down like some variables that we could use for this right now. So S is the amount of salads that, they sold, and D is the amount of drinks. And one thing we know for sure is that S plus D, like when you add up all the items sold, let's see, selling a total of 209 salads and drinks, 209. So that's going to be 209. So when you add the amount of salads you sold plus the amount of drinks you sold, you're going to get 209. A lot of students watching this, they've probably seen this kind of thing like a million times. But the other equation that we get set up has to do with like how much money was made, right? So we have 836.5. I'll just put that here because I know I'm going to anyway. I'll just call it 0.5. And it's like 650 times however many salads we sold. So I'll call that 6.5 S plus, $2 times the amount of drinks that we sold. And that equals 836.5. Now we want to know how many salads were sold that day, right? So in other words, we want to solve for S, right? Well, the way I like to handle substitution problems, first of all, we're going to use substitution. That's the first thing to note. Okay, we're going to use substitution to figure this out. And when I like to do, substitution, or when I do substitution, I always ask myself, okay, what am I solving for at the very end? And then the first move with this like simpler equation is to solve for the opposite. And that always works out. So I'm going to solve for D over here. D is 209 minus S. Okay, 209 minus S because I subtracted S from both sides. All right, so that's always the first step when you're doing substitution and you're specifically solving for a variable, in this case salads. You solve for the opposite. And now I can plug this in for D down here, right? So I end up with 6.5 S plus 2 times 209 minus S. And that equals 836.5. I'm going to multiply everything across the board by 10 because these decimals annoy me. Okay, so I'm multiplying 10 times the whole thing. And that moves the decimal place over once. So that becomes 65S plus 20 times 209 minus S. Notice how when I multiplied this term by 10, because the 10 went in there, it only affected the 20 on the outside. It doesn't affect what's on the inside. And then I have equals 8365. Okay. And yeah, taking it from there, 20, it's going to be 65. I'll put this just to make it not look like a 5. We'll do it in yellow. And then distributing 20 into that is going to give me 4180. And that's going to be minus 20. We'll leave the S in yellow. And that equals 8, 365, yeah. All right, so I'm going to trust every student watching to know how to solve for s. From here, obviously 65s minus 20s, that's going to be 45s. We're going to be subtracting 4,180 from both sides. And then we're going to be dividing by 45, and that will give us 93. So we have s equals 93, and that is right here. Good sign, moving on. Okay, Alma bought a laptop computer at a store that gave a 20% discount off the original price. The total amount she paid was P dollars, including an 8% sales tax on the discounted price, which of the following represents the original price of the computer in terms of P. Okay, so this is a very tricky problem, actually, because think about it. You had bought a laptop computer. There was 20, and by the way, the laptop computer had like an original price. We'll call the original price X. X. And that is the original price. I'll just write it like this. And then there was apparently 20% taken off of that. But she then paid P dollars to the cashier, and part of that money that she paid to the cashier had 8% sales tax included, right? So, which of the following represents the original price X in terms of P? I have found it helpful in the past to treat the price as just 100, or the number as just 100, and then kind of apply all the percent changes to that number, to 100. Now you might be asking yourself, well, why can you make up your own number 100? Like, for example, I'm going to treat X as 100. And the reason is because on the SAT, anytime you have like a word problem that features variables, like P, and in a way this is kind of a variable, X equals the original price of the laptop. Anytime you have a word problem that features variables on the SAT, and there's variables in the answer choices as well, well, then you can make up your own numbers. All right, so I'm actually going to call X 100, and we're going to sort of follow the price of everything as we apply these changes. So when there was a 20% discount off of this, it then became $80. Right? And by the way, that's why I'm using $100 as the original price, because it's very easy to apply percent changes to the number 100. 20% off of 100 is 80, so it's $80. But she didn't pay $80. She paid a certain amount of money that included 8% of 80 on top of this, right? So the question is, what is 8% of 80? And if we add that to 80, then we can figure out what P is, right? Because P is the amount of money she paid the cashier, which is 80 plus tax, and the tax happened to be 8%, right? So the question that I could kind of look at over here is, what is 8% of 80? Let's just find that out right now, And what is X? The word is means equals, 8% is 0.08. The word of means multiply, and 80 is just 80. So all we have to do is multiply 0.08 times 80, and that is 6.4, also known as $6.40. So really, the person ended up paying $86.4. And that's P, because she paid the cashier P, so that is P. So I'm going to actually just really highlight that we have a number that we could say is P now. It's 86.4. And we want to know which of the following represents the original price of the computer in terms of P. Well, once again, the original price was 100, right? So which of the following represents the original price? So in other words, which one of these equals the original price when we plug in 86.4 for P? Well, I can already tell 86.4, if it was P here, that would not give me 100, if for no other reason than the fact that the units digits wouldn't line up. This would be 86.4 divided by 0.88. And that one, I'll just plug in my calculator. 86.4 divided by 0.88 is 98.18, so that's not quite it. It's pretty close, though, but these are gone. 0.8 times 1.08 times P, and P again is 86.4, in the calculator is 74.6496, so that is gone, and by process of elimination, that's the answer. Moving on. The data in the table above were produced by a sleep researcher studying the number of dreams people recall when asked to record their dreams for 1 week. Group X consisted of 100 people who observed early bedtimes. Group Y consisted of 100 people who observed later bedtimes. If a person is chosen at random from those who recalled at least one dream, what's the probability that the person belonged to group Y? So this is the sentence, or yeah, it's really a question, right? That's the question right there. If a person is chosen at random from those who recalled at least one dream. Okay, so the totals are down here and the totals are here. People who recalled no dreams, 1 to 4 and 5. And we're analyzing if a person is chosen at random from those who recalled at least one dream. So that is going to be all of this, right? It's not going to be this because these are the people who didn't recall any dreams. We're analyzing the people who recalled at least one dream, and that takes place here. What's the probability that the person belonged to group Y? Well, group Y is the sum of these two, right? It's, these people and these people belong to group Y, so I'm actually going to kind of put a box around them as well. And we want to know what's the probability that, this is the case out of all of this. Well, probability is want over possible. When I say want, it really just means like the variable that you're analyzing in a way. And in this case, we're analyzing how many people belong to group Y. So that's going to go up here. So that's going to be, I'll just write 11 plus 68 up there, because of course that's right here. We're going to add those two. That's the group of people that we're analyzing in this case. And that's going to be over the possible outcomes that you had to pull from the population that you're honing in on. And the population we're honing in on is this green population. So that's going to be, I'll even write it in green, that's going to be 28 plus 57 plus, was it 11 plus 68? So actually including those two. And it looks like these are all fractions. So yeah, 68 plus 11 would be 79, which is right there, but we have two of those, right? 68 plus 28 is 96, plus 11, that already gets me over 100, so this is the answer right there. Because this had a denominator of 100, as soon as I see that this denominator is more than 100, we're good. All right. Annual budgets for different programs in Kent's list. Like, look at this table above, list the annual budget in thousands of dollars and thousands of dollars. So that's something to take note of, right? For each of the 6 different state programs, right? So they spent, this amount of money each year on this stuff, blah, 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 blah. All right, which of the following best approximates the average rate of change in the annual budget for agriculture and natural resources in Kansas from 2008 to 2010. So agriculture, natural resources in the top row, and we're looking from 2008 to 2010, and they're saying the average rate of change, in a way that is like the slope. Rate of change means slope, and and notice how it says per year. It's like money per year, right? So it's like the increase in money per year. Well, you could take this number and subtract this number. So it's really 488,106 minus what it used to be, which is 358,708. And then you want to be careful with this part where you are going to be dividing it by the change in year as well. But if you think about it, it's only 2 years between 2008 and 2010. So you don't want to be fooled by the fact that there's 3 cells here. It's a 2-year change. It's year 1 and year 2, right? So 2 years had gone by. So, I mean, if you wanted to, you could always just be like 2010 minus 2008. That's another way of doing it. And that would give you 2 years down below. And yeah, this is just a matter of plugging that into your calculator and then dividing it by 2, because this would give you 2. And that's going to give you, 64699. Now we do want to remember that this is in thousands of dollars, right? So we could tack on 3 extra zeros there. And really, that's what we're dealing with. So it's like, I don't know, 65,000 about, which is right there. So that's how you do that. Of the following, which program's ratio of its 2007 to its 2010 budget is closest to the human resources ratio from 2007 to its 2010? So the order by which they mention those, words, or dates, I should say, matters. And the order is 2010 to 2007 rather to 2010. So one way of representing that ratio is 2007 to 2010 with a colon. But another way is to represent it as a fraction. Just to keep that in mind, I could have, it's like year 1 is 2007 and the other year is 2010. So it could be 2007 over 2010 as well. So first let's figure out, okay, well, what is the human resources program's ratio of its 2007 to its 2010? Well, human resources is right here, 2007's right there, and there's 2010. So it's going to be like 4 million, even though it's thousands, we're just going to treat it like million. It's like 4 million to basically 6 million, right? Wouldn't that round up to 6 million? So that's really 4 to 6. And that would reduce, if we were to represent that as a fraction, it would be 4 over 6. And very clearly we could see that that's 2/3, right? So that's one way of kind of estimating the ratio of the human resources program from 2007 to 2010. It's 2 to 3. Okay. And the question is, which program's ratio is closest to that? Is it agriculture, education, highways, public safety? So where is a similar ratio of 2 to 3 from 2007 to 2010? I would say this one is certainly a candidate, right? Because that rounds down to 2 million, that rounds down to 3 million. Do we see any others? This is maybe about half, 1 to 2. No, this is about the same. Yeah, it's all about education. That's 2 to 3. So that is the answer. Moving on. Okay, which of the following is an equation of a circle in the xy plane with center 0, 4 with radius? Okay, well, first of all, what is the equation of any circle? The equation of any circle is x minus h squared plus y minus k squared. Y minus k squared. And that equals the radius squared. And it is the case that HK is the center, and R is the radius. Okay, so the bottom line is we would totally know the equation of this circle if we just knew the center and we just knew the radius, because then we would just plug it right in. right? Well, they give us the center. It's 0, 4, so 0, 4, so it's going to be x minus 0 and y minus 4. Now, x minus 0 is just x, so this is going to be x squared, right? So it's really going to be x squared plus y minus 4, right? I'll write that underneath. 0, 4 with our circle. So x minus 0, also known as x squared, y minus 4, also known as y minus 4 squared. So clearly, this is a candidate. This is a candidate, right? The y plus 4s we want to be gone. The question is, this says 5/3 over here. This says 25 over 9 over here. Question is, what is the radius? I mean, if we had the radius, all we'd have to do is square it. And then we would have the number that we need over here, because it would be here, right? So bottom line is, with this one, if you were to graph it, the center would be at 0, 4, which is like right here, let's say. And then one of the endpoints is at 4/3, which is really 1 1/3, comma 5. So that would be, around here. I wish this graph was better. This is the dinkiest little graph I've ever seen. But nonetheless, the radius, like the circle goes around and it's like that. So the radius is the distance between those two. That's really what I'm getting at. All right, the radius is the distance between those two. So we could use the distance formula to figure it out. And the distance formula is this. All right, so in a way, you are really being tested, where it's like x minus x, y minus y. You're being tested on your ability to remember this stuff. Now, I know it's usually like x2 minus x1, y2 minus y1, but I'm going to give you a secret. You ready for the secret? It actually doesn't matter. It's just x minus x, because when you square it, it's going to turn into a positive y minus y. So let's do that. We have all this, and then it's going to be, 0 minus 4/3, and 4 minus 5. And that's going to become 16 over 9, 9 plus 1. Now, how did I get that? Well, negative 4/3 squared is 16 over 9, because this exponent of 2 applies to the top and bottom, so it becomes 16 over 9. 4 minus 5 is negative 1, and negative 1 squared is positive 1, so we have a plus 1 there. Now, it'd be nice to have a common denominator. Let's call this 9 over 9. 1 is 9 over 9. So, in fact, I will rewrite it as 9 over 9. And then we have 25 over 9. Because we keep the denominator, simply add the numerator, so we have the square root of 25 over 9. So the radius is coming up. It's going to be 5 over 3. That is the radius. Now we want to be careful because that's the radius, but according to the equation of a circle, which says this, we want, on the right-hand side of the equal sign, the radius to be squared. So the question is, what is this squared? Well, it so happens that squaring it would give us 25 over 9 again. So the answer is that one, right? Because we want the radius. We found the radius, but we have to square it, and it becomes 25 over 9 as a result. Moving on. Okay, the equation above expresses the approximate height h in meters of a ball t seconds after it's launched vertically upward from the ground with an initial velocity of 25 meters per second. After approximately how many seconds will the ball hit the ground? Well, from experience, I know that this is a quadratic equation, first of all, which means it's a parabola. And the reason I know that is because there's this exponent of 2. It's got a degree of 2. And this is negative, so that means that the horns of the parabola point downward. And that makes total sense, seeing as how what we're doing is we are tracking the movement of a ball that goes like up, you know, and then down. And typically it's t for time over here. And in this case, it would be the h for height with regards to the y-axis. And, you know, it starts at the ground, and then at a certain amount of time, it hits its peak, and then as time goes by, it goes down, and the height becomes once again 0. Okay, so we want to know after approximately how many seconds will the ball hit the ground. So in other words, when does h equal 0? When does the height equal 0? So that is relatively simple algebra where you just set h equal to 0, and you figure out, you know, what t is, you know, which t corresponds with h being 0. And here I set h equal to 0, and let's keep in mind before we proceed that clearly h is 0 here, which is the takeoff point, and clearly h is 0 here, which is the landing moment. And we're more interested in the landing moment, not so much this moment. So nonetheless, let's continue to solve this. You could factor out the GCF. It is most definitely t, right? And in fact, I'm going to factor out a negative t because I see this negative here in front of the t squared. And I'm just going to factor out that negative just to kind of get it, in a way, out of the way. All right, so we have 4.9 t minus 25. And to be very clear, when I factored out this negative, it changed the sign of this one. If you're not sure about that, you could always redistribute that negative t back in, and then you would certainly get negative 4.9 t. Negative t times negative 25 is positive 25t. Now, it is the case that if this t was 0, then it would be 0 times whatever this is, and then the whole thing would be 0. So one of the sort of, at least algebraic answers, is that t equals 0, right? That's one of the answers. And the other one, you know, the other answer, the other solution is what you would get if you set this parentheses equal to 0, because the bottom line is if this whole parentheses equaled 0, then it would be 0 times whatever that is, and then it would equal 0, right? So you do have to kind of go off to the side and set up perhaps a separate equation where it's 4.9t minus 25 equals 0, and adding, you know, 25 to both sides would give us 4.9t equals 25, and then of course we're going to divide by 4.9, and we would have approximately 5.1. You can use a calculator for that. So that's 25 divided by 4.9. So t equals 5.1. So they say after approximately how many seconds? So that means we are allowed to round it, and that is the answer 5. Moving on. Okay, Katarina is a botanist studying the production of pears by 2 types of pear trees. She noticed that type A trees produced 20% more pears than type B trees did. Based on Katarina's observation, if the type A trees produced 144 pears, how many pears did the type B trees produce? So that could be seen certainly as a system of equations, interestingly enough. So we will have A equal the number of pears that, you know, type A trees produce, number of pears type A produces, and we will have B equal the number of pears type B produces. So what we have learned from the problem is that type A, this one, produces 20% more pears than type B produces. So we've learned extra information about this one for sure, where, you know, we could also say that A equals 20% more than B. So that means it's B, which is the amount of pears that type B trees produce, plus more, plus 20% of itself, right? So that's 0.2 times B. So the amount of pears that type A trees produce equals the amount of pears that type B trees produce plus 20% of the amount of pears that type B trees produce. And when you simplify that, that becomes 1.2b. So that is a fact. And then, according to them, type A trees produced 144 pears. So you could totally set this equal to 144. Right? 144, because that is literally A. That is literally how many pears type A trees produced. So that's going to be 144 equals 1.2b. And then dividing both sides by 1.2 gives us 120, 120. And that is the answer. Moving on. A square field measures 10 meters by 10 meters. 10 students each mark off a randomly selected region of the field. Each region is square and has side lengths of 1 meter, and no two regions overlap. The students count the earthworms contained in the soil to the depth of 5 centimeters beneath the ground surface in the region. The results are shown in the table below. So it looks like there's 10 little regions here that are each 1 meter by 1 meter. Which of the following is a reasonable approximation of the number of earthworms to a depth of 5 centimeters beneath the ground surface for the entire field? Okay, so I'm going to draw a diagram to kind of explain what's happening here. Let's say this is a section of dirt, okay? And I'm going to fill this in to sort of represent exactly what they're talking about. Okay, so it got a little weird over here, but you can think of this as being 5 centimeters deep. 5 centimeters deep. And this is the piece of the field that basically we're talking about. We have a square field, measures 10 meters by 10 meters. So this is 10 meters, this is 10 meters. And they're looking for earthworms in the dirt, basically. The students count the earthworms contained in the soil to a depth of 5 centimeters. So this is the depth of 5 centimeters. So maybe we could say that this is one of the regions. Maybe we could say that this is one of the regions, like maybe that's, region B, and then you have one over here that you're studying, and so on. So I'm actually going to fill this in with 10 different regions that represent region A through J. So let's imagine these are the 10 regions that are represented on this table. So which of the following is a reasonable approximation of the number of earthworms to a depth of 5 centimeters beneath the ground surface in the entire field? So basically one thing you could do is you could realize that, okay, well, we're studying just these 10 blocks, but we're hoping that these 10 blocks, these 10 regions are going to be like, representative of what's going on in the entire field, right? And how many regions are there in the entire field? Well, there's 100 total regions in the entire field. How do I know? It's going to be 10 by 10, right? And how do I know that? Well, each region is a square and has side lengths of 1 meter, right? So this is a square with a side length of 1 meter, at least from the top view, right? So anyway, all you have to do, therefore, is add all these up, find out how many earthworms are in these sections, right? And then just multiply it by 10. That's all you have to do. So when you add these, you get 1,471. 1,471. So that's how many earthworms are in these red regions here when you total it all up. Now, like I said before, you're going to want to multiply that by 10. All you have to do is tack on a 0, and you have successfully multiplied it by 10. That's 14,710. And they say, which of the following is a reasonable approximation? Well, that's closest to answer choice C. So answer choice C is the answer. Moving on. If the system of inequalities y is greater than or equal to 2x plus 1 and y is greater than 1/2 x minus 1 is graphed in the xy plane above, which quadrant contains no solutions to the system? So as you may recall, when you have like inequalities and you're graphing them, it often is the case, if not always the case, that you have to sort of shade a region, right? My thought is, let's actually graph these, get a sense of what's going on over here. and then, find out which quadrant contains no solutions. Now, before I move on, what do they mean by it contains no solutions? That means that there is no a double shaded region, right? Because the solutions to the inequalities here would be the double shaded regions. So we are interested in which quadrant has no double shaded regions. Now I'm going to go ahead and blow this up. I'm going to go ahead and just use the graph that they give me. And we're going to just do sort of an approximation. So 2x plus 1 has a y-intercept of 1. So that would be right around there. And it goes, according to the slope, it's up 2 over 1. So that would be something like that. And I know it's a solid line because it's greater than or equal to. Now, with regards to the shaded region, this says y is greater than that. The way that I like to read that is y is greater, or we could say the solution is greater than the line. Greater than or equal to the line. So I'm going to shade above the line. That's the way I like to do it. There's different ways of going about that, but that's the interpretive strategy I use. Then we have and y is greater than 1/2 x minus 1. So greater than means it's going to be a dotted line. There's no underline underneath this, which means it's going to be a dotted line. The y-intercept is -1. I'll do this in blue. So this is like that. And, it goes up 1 over 2 according to the slope. Up 1 over 2. And y-intercept is 1, so it's going to go up 1 over 2. So it's going to be something like that. And I'll just go ahead and draw that dotted line. And they say that y is greater than, right? So we want to really shade above that, right? And then you ask yourself, well, where is the double shaded region? Clearly the double shaded region is, all of this stuff right here. I could have shaded this area, but I didn't before. But it's everything above the blue line and above the red line, right? So which quadrant just got left out of the double shaded region? Well, clearly quadrant 4 did, and that is the answer. Quadrant 4 is the quadrant that contains no solutions to the system. There it is. For a polynomial p of x, the value of p of 3 is -2, which the following must be true about p of x. X minus 5 is a factor. All right, well, I have a feeling it's deep, but I'm going to explain why right now. First of all, anytime you have like some number like 5, and then you divide it by 3, well, it's going to be 3 times, 1 plus the remainder of 2, right? Where, maybe we could say that that is the divisor. This right here is what we call the quotient, and this right here is what we call the remainder, and this is the dividend. And in case that's not exactly clear, we could sort of look at the old school long division scenario where it's 3 times 1 here, and then 3 times 1 is 3, so we subtract that, and then we end up with the remainder, right? And the quotient is always this thing on top, and the divisor is right there, and the dividend is right there. Okay, now that might be even more confusing. So, but that's basically the structure of some number divided by another number gives you a quotient, and then you sort of add the remainder, and you could always set up this equation. I'm going to leave that there for now. I'm drawn to this one because there's the -2 here, there's a -2 here, so it's sort of, this is the one that interests me more than anything, which is why I kind of got into all this. If we were to apply this structure in this reasoning process to polynomials, let's just be clear about it. It would result in something like p of x equals, we'll just say divisor. times the quotient, which I'm actually going to call q of x, plus the remainder. All right, so p of x is going to be some divisor, who knows what that is, times the quotient, plus the remainder. And because we're talking about this polynomial, potentially being divided by x minus 3. So let's investigate that situation by filling that part in. So we have p of x equals x minus 3 times some quotient plus the remainder, right? And furthermore, they say that when it's p of 3, the value is negative 2. So p of 3 is apparently negative 2, which also, since it's p of x equals this whole thing, p of 3 should also be, 3 minus 3 times q of 3. I'll just make this green too. Plus the remainder. Right, so p of x equals this whole thing here. P of 3 equals negative 2, but p of 3 also equals this whole thing when you put 3 in for x, right? And that's what we're doing there. So I'm kind of mostly interested in this point, in this part of the equation that says that negative 2 equals 3 minus 3 q of 3 plus r. And let's kind of walk through it. 3 minus 3 is just 0, so that's going to be 0 times q of 3 plus r. And some of you could already see where this is going. 0 times anything. We don't even need to know what q of 3 is. 0 times anything is equal to 0. So negative 2 equals r. And that is why answer choice D is the answer. The remainder, when p of x, which is right here, is divided by x minus 3, so that's represented right here. P of x is divided by x minus 3, because the divisor is this number that gets multiplied to the quotient, is negative 2. So we essentially sort of checked whether or not r would equal negative 2, when it's p of 3 that we're looking at. Okay, so hopefully that makes sense. It's kind of a somewhat strange and confusing problem. I think what it comes down to is just understanding this structure more than anything else, or maybe even you could say this structure. It might even be worth memorizing this structure here, where it's like p of x, that's some polynomial, equals some divisor times whatever the quotient is plus the remainder, and sort of piece it together from there. Moving on. Okay, which of the following is an equivalent form of the equation of the graph shown in the xy plane above, from which the coordinates of vertex A can be identified as constants? It's really that last part that's the interesting part. From which the coordinates of vertex A, which is right there, can be identified as constants in the equation. Well, let's get clear about what the coordinates of vertex A are, right? Let's take a look at that. So when you blow it up, looks like we have an x value of 1. We have a y value that's a little bit, in a way you could say, less than negative 15, right? It could be negative 16, it could be negative 17. Nonetheless, it's safe to say that the coordinates are like basically 1, negative, let's just say 16. And we're going to acknowledge that that might be an approximation. And looking at the answer choices, which of the following is an equivalent an equivalent form of the equation of the graph shown in the xy plane. So we want an equation of this, but it has to be an equation such that the coordinates of vertex A can be identified as constants. Well, again, the coordinates of vertex A are 1 and potentially -16. I don't see any of that here as a constant. I don't see 1 at all here. Let's just focus on 1. I don't see 1 here either. I do see 1 here, and actually I see a -16. And by the way, that is vertex form. Vertex form is when the parabola is written like that, where h, k are the coordinates of the vertex. Well, we can very clearly see that that is exactly what's happening in this situation of vertex. And just to be clear, h is the number that's being subtracted from x, k is the number that's being added to this term. Well, the number that's being subtracted from x is 1, and the number that's being added to this term is a -16. -16 is currently being added to this term right there, so hopefully that makes sense. Moving on. Y can husk at least 12 dozen ears of corn per hour, and at most 18 dozen ears of corn per hour. Based on this information, what is a possible amount of time in hours that it could take Wyatt to husk 72 dozen ears of corn? Okay, so at least 12 dozen ears of corn per hour and 18 dozen ears of corn per hour. So since 12 could be included in that, and since 18 could be included in that, you really have a choice. I mean, you could divide 72 by 12, you could divide 72 by 18, because we want to know, okay, if he does this amount per hour, how long will it take for him to do 72? Clearly, that's like a division problem, right? Same with the 18. So I'm actually going to focus on the 12 because I can just immediately see that 12 goes into 72 for sure. And 12 divided by 72 is 6. And that is one of the answers that the SAT would accept. So clearly, this is not a multiple choice problem. This is a grid-in problem. So it is the case that the SAT would accept 6 as one of the possible answers. You could have also divided 72 by 18, and you could have also, perhaps found a number between 12 and 18 and then divided 72 by that as well, and that would have worked as well. All right, moving on. The posted weight limit for a covered wooden bridge in Pennsylvania is 6,000 pounds. A delivery truck that is carrying X identical boxes, each weighing 14 pounds, will pass over the bridge if the combined weight of the empty delivery truck and its driver is 4,500 pounds. What is the maximum value for X that will keep the combined weight of the truck driver and boxes below the bridge's posted weight limit? So we want to make sure that we're below it, right? We want to make sure that we're not at the bridge's posted weight limit. So so I could already see this might be a good idea to set up an inequality. So the weight limit is 6,000, and we want to make sure that we're below that, right? So we're going to do a little less than here. And a good sort of expression that we could use is, okay, X, we don't know how many identical boxes, X identical boxes, it could be 2, it could be 3, who knows. But each one of the boxes weighs 14, so it's definitely going to be 14 times X, right? 14 pounds times however many boxes you're dealing with. If the combined weight of the empty delivery truck and its driver is 4,500, so in other words, even without the boxes on the truck, each box weighing 14 pounds, even without those, basically the truck with the driver or whatever is 4,500 pounds. So we do have to write that 4,500. And that essentially is going to be the weight of the truck. You have the 4,500 pounds to start with, and then when you load the boxes up, it's going to be 14 pounds per box. So we want to know what is the maximum possible value for X. Now, really, all you have to do is solve this inequality. You could sort of ask yourself, in a way, it's almost like asking yourself, what x would cause this expression or the weight of the truck to equal 6,000, and we want to just make sure that we're, at least 1 pound less than that, right? So subtracting 4,500 from both sides is going to give us 1,500, and then dividing both sides by 14 is going to give us 107.14. So that's 107.14 in the calculator. I use a calculator for that. Now, the bottom line is, whatever the poundage of the truck is, what we've just discovered is that if you have, 107.14 boxes, then you've hit the limit, right? So we want to make sure that we have less than 107.14 boxes. Now, first of all, some of you might be noticing that it doesn't really make sense to have a decimal when we're talking about how many boxes, right? Because we want to look at the maximum possible value for x, also known as the how many identical boxes, right, could the truck be carrying. It doesn't make sense to have a decimal here. So some of y'all might realize that rounding it to 107 would make sense. And it is the case that 107 boxes is the answer, because whatever the amount of boxes is, it's got to be less than 107.14. It doesn't even make sense to have this decimal anyway, and of course we need to round it down, because we can't be this amount and it can't be more than this amount. It has to be less than this amount, and the maximum value that x could be therefore is 107. All right, so that was very wordy, but hopefully that makes sense, and moving on. Number of portable media players sold worldwide each year from 2006 to 2011, right? So clearly that's denoted here. Number of sold in millions. So definitely take note of like the unit of measurement. In this case, it's million. According to the line graph above, the number of portable media players sold in 2008, which is right there, is what fraction of the number sold in 2011. So what fraction? So in other words, it's like we're going to have 2008 is the part, and we could say 2011 would be the quote-unquote whole, and fractions are such that they are part over whole. So it will be the 2008 amount, which is 100 million, all over, I'll just write 2008. I'll write AD to make sure it's clear that it is a date, right? A year. And then 2011 is going to be 160, and clearly that is 2011, right? And yeah, so that totally reduces, does it not? I mean, you could think of getting rid of the zeros, and then you could be like, okay, well, 10 over 16, that's going to be 5 over 8. So that becomes 5 over 8, which is the answer. The SAT would most definitely accept that. Moving on. A local television station sells time slots for programs in 30-minute intervals. If the station operates 24 hours per day every day of the week, what is the total number of 30-minute time slots the station can sell for Tuesday and Wednesday? So they say Tuesday and Wednesday, which is strangely specific, but at the end of the day, what they're really asking for is, what is the total number of 30-minute time slots that could be sold in 2 days, right? That's essentially what they're saying. In a way, they're kind of baiting you by throwing out a specific day, like the name of the day, but really we want to know, again, how many, what's the total number of 30-minute time slots you could sell in 2 days? Well, station operates 24 hours a day, and the station sells time slots for programs in 30-minute intervals. Well, I'll tell you, that is a lot of intervals. I mean, it's like, let's find out how much would be in 1 day. How many 30-minute intervals, we could say, are in 1 day? Well, the bottom line is 30 minutes, as everybody knows, is a half hour, right? And there's 24 hours in a day. So clearly, how many half-hour time slots are there in, 24 hours? Well, there would be 24 times 2, which is 48. There are 48 30-min time slots in one day, right? One day. But again, we're not interested in one day. We are interested in how many would be in 2 days. Well, all you have to do is multiply 48 times 2, and that's going to be 96. That is the answer. There are 96 30-minute time slots in 2 days. I'll even write 2 days. All right, so that's how you do that one. Pretty easy, actually. It's just a matter of not getting baited by the specifics here and just being, carefully reading the problem and, understanding exactly what they're asking for. Okay, cylinder. Dairy farmer uses a storage silo that is in the shape of the right circular cylinder above. If the volume of the silo is 72 pi cubic yards, what is the diameter of the base? The volume is 72 pi cubic yards. So they give you the volume and they give you the height. At the end of the day, we want the diameter. Now, many of you guys know diameter equals 2 times the radius. So the bottom line is if we had the radius, then we could find the diameter, obviously, right? And just multiply it by 2. So if the radius ends up being 5, well, then the diameter is 10, right? And so on. But the question is, well, how do you find the radius? Well, that's pretty straightforward. You just use the formula for the volume of a cylinder, which I'm going to write right here. It's pi r squared times height. Now, for those of you watching the video, do not fear. This formula is in the reference guide at the beginning of the SAT math section. So you don't even have to memorize this, And I'm going to put a little C down here. It's the volume of a cylinder. And just to make sure it's not confused with the volume of a circle, I like to be as thorough as I can without wasting time. So we have cylinder right there, right? All right, so nonetheless, they give you the volume. It's totally 72 pi. So they actually gave you the volume of this one. And we know it's going to be pi times r squared times the height, but we have the height. The height, of course, is 8. So it's going to be that, right? Now I'm going to kind of do this all at once just to save time. I'm going to divide the entire thing by pi and 8. I'm going to just do that right away, okay? Just to save time. And as a result of that, this 8 cancels with that, and this pi cancels with that, and we are therefore left with r squared equals... Let's think about this. 72 over 8 is going to be 9 over 1. It's going to be 9 over 1. And then the pi's cancel. So we end up with just a 9 over here, yeah? So we have 9. R squared equals 9. And at the end of the day, we're not looking for r squared. We're looking for r. So we'd have to take the square root of both sides. Now, I'm not going to draw that. I'm just going to write r equals 3. I think most people at home understand that. And just for the record, whenever you do the square root of both sides, you might want to go plus minus, and therefore under, in algebra circumstances, it would be plus minus 3. But in this case, we're dealing with a real world figure, so r must therefore be the positive version, right? It's got to be positive 3. It doesn't make sense to have a radius of negative 3. So we have the radius. Now, you want to be careful because this is a grid-in question. And some students would make the mistake of thinking that that's the answer, but the truth is it's not the answer. You have to be careful. The final answer is, what is the diameter? Look, they even underlined it for you. That's them being nice, by the way. And therefore, diameter is 2r, so the diameter is 2 times 3, which equals 6. That's the answer. The answer is not 9. The answer is not 3. The diameter is 6. Moving on. Okay, disgusting looking gobbledygook rational function. For what value of x is the function h above undefined? In other words, what value of x would cause this denominator to be 0? right? Because undefined means the denominator is 0. That's what it means. So let's literally force the denominator to be 0 and find out what x corresponds with that situation. So that's really all I have to do, and then whatever x is, well, that is the answer. My thought is there's really multiple ways of doing it. I mean, the bottom line is this is quadratic, so it could actually be factored as is. I want to avoid confusion for, like, some students would have no trouble with that. Some students might even know what the heck I'm talking about right now. But I think most students would prefer just foiling this out, simplifying it, and then taking it from there. So we're going to do that right now. The truth of the matter is x minus 5, I mean, that's really just, x minus 5 times x minus 5. And you might want to just do FOIL there. And most students watching know that that will be a matter of, first times first, which is x squared. And then we have outer times outer, which is negative 5x. And we're going to combine that with another negative 5x. So that's going to give you a negative 10x. I'm actually just going to save time by writing that. Once again, x times negative 5 is negative 5x. X times this negative 5 is negative 5x. And when you combine the two, you're going to get negative 10x. And then as far as last goes, it's going to be negative 5 times a negative 5, which is a positive 25. And then distributing this 4 is, of course, going to give us plus 4x minus 20. And then we still have this plus 4. And then we have a 0. The like terms are underlined. We have an x term and x term. We're going to have a bunch of constants right there. And then when you combine them all, there's only one x squared term. The negative 10x and the 4x gives me a negative 6x. The positive 25 and the negative 20 give me a 5 plus 4, which is 9. And that equals 0. I can already see this is only going to give us one x value, which is a good sign because they literally asked for what value singular of x. So yeah, this could be factored. You actually want to, so it's almost like you had to FOIL this part just to get it into a single string, and then you had to simplify it, and now we're actually factoring this thing, right? So, a little tricky maybe, but it's going to be x minus 3 times x minus 3. Now, how did I do that? Well, I asked myself what factors of positive 9 are such that when I add them together, I get a negative 6. So again, what factors of positive 9 are such that when I add them together, I get a negative 6. And the truth of the matter is, negative 3 times negative 3 gives me positive 9, and negative 3 plus negative 3 gives me negative 6. So I have properly factored this. And as many people know, the bottom line is this is really just x minus 3 squared equals 0. And, multiple ways of doing this one. I think most students probably already know that the answer is 3, but one way of going about it is you could take the square root of both sides. That gets rid of this exponent, so the square root symbol destroys that exponent. The square root of 0 is just 0, so the next line could just feature a 0, and then we're left with just x minus 3. So x minus 3 equals 0, and adding 3 to both sides would give me x equals 3, and that is most definitely the answer to that problem. All right, so these are the last two questions here. Jessica opened a bank account that earned 2% interest compounded annually. Her initial deposit was $100, and she uses the expression 100 times x to the t power to find the value. All right, so after t here, so t represents time in this case. I mean, really the equation is as follows. It's really, we say y equals 100 times x raised to the t power. And they had kind of given you the expression. But at the end of the day, this is, how much money she put in the bank right away. And then over time, the amount of money in the bank increases by a certain amount. So as time goes by, the whole amount of money she sort of has in the bank due to like interest compounding ends up being more than 100. So if you want to know how much money she has in her bank account at any given time, Well, you just plug in a certain number for t, a certain amount of years gone by, and that will give you a calculation that gives you y, and y in this case would be the amount of money she has in the bank after t years. Okay, what is the value of x in the expression? Okay, so it's 2% interest. I think it's probably worth just simply memorizing the equation for like interest. And that would be something along these lines where it's y equals p, which is the principal, times 1 plus, we could say, r over 100 raised to the t power. I think that's probably going to be the best way to approach this problem, is just kind of remember that. And you might be asking yourself, well, what does all this stuff stand for? Well, let's start with the p. I mean, p basically is the principal, and that means how much money you started with. And then there is this r right here, which is the percent, like literally the number, the percent of interest that's compounded. All right, now it's annually, which means every year, okay? Continuous compounding is a sort of a different situation. This is just compounding annually. And this is literally, like, r is literally going to be the number of percent. So if it's 2%, r in this case would be 2, right? If it was 30% interest, then it would be 30 right there, okay? So just to be clear about that. So again, r represents the percent interest. And then finally, and this one's probably the most obvious one, and that would be t is the time gone by, in years usually. So again, I think that this equation, sometimes they'll put like an a over here. We'll just leave it as y. All right, y represents how much money you have in the bank after a certain amount of time. All right, so in fact, I'll write that. So we will say that is how much you have after t years. That's what y equals. All right, so hopefully that makes sense. Looking at this problem, and again, it's good to memorize this. It's good to memorize this equation, okay? So we want to know what's the value of x in the expression. Like, what is this? Well, if it earns 2%, this whole parentheses thing is going to be 1 plus 2 over 100, right? 2%, so it's going to be 2 over 100. So it's going to be 1 plus 2 over 100. Now, 2 over 100 is just 2/100ths, right? So this in decimal form could be 1.02. So I'm going to write that. I'm going to write y equals 100, which is the principal, times, I'll break it down. 2 over 100 raised to the t, and again, that's based off of this formula. They told us the 2% interest, and 200, 2 over 100 is really equal to 0.02. So this becomes 1.02 raised to the t power. So x is 1.02. All right, pause, rewind the video if need be to understand that better. Okay, Jessica's friend Tyshawn found an account that earns 2.5 interest compounded annually. Tyshawn made an initial deposit of 100, same deposit. At the same time, Jessica made the deposit. After 10 years, how much more money will Tyshawn's initial deposit have earned than Jessica's initial deposit? Round your answer to the nearest cent and ignore the dollar sign when grading your answer. Okay, so after 10 years, how much more money will Tyshawn's initial deposit have earned than Jessica's deposit? So apparently 10 years have gone by. Let's find out how much Jessica would earn after 10 years. So in other words, because we're going to be comparing how much Jessica has and how much Tyshawn has. So we want to find out, well, let's just find out how much Jessica would have. Like, we'll start there. So if you were to do 1.02 raised to the 10 power and then multiply that times 100, you would end up getting, you would end up getting a kind of a decimal where it's like 1.21.89 or whatever. This says round to the nearest cent when gridding the answer. So I'm going to round to the nearest cent when it comes to this thing, it's going to be 1.21 or 121.90. $121.90. So I'm actually just going to round it right there. And that's really Jessica. Like, that's how much Jessica has. So we could keep the Y here, but we'll say Jessica. That's what she has after 10 years, yeah? But we want to know, how much does Tyshawn have after 10 years? And in fact, Tyshawn's going to have more than Jessica after 10 years. And we want to know, how much more is Tyshawn going to have? So, let's see. Tyshawn, his account earns 2.5% interest. So really it's going to be the same deal where we're going to use this formula here and, apply it to Tyshawn's situation. So in his case, I'll actually just call it capital letter T for Tyshawn. And that's going to be 100 times 1 plus 2.5 over 100 T. And we're really interested in 10 years. So this T is about to be 10. But on the next line, I'll write a 10 here, but on the next line, let's turn this into a decimal. I mean, 2.5 over 100. Well, anytime you divide by 100, it's really moving the decimal place over twice to the left. So it'd be like, so it would really be 2.5 over 100 is really 0.025. So this is going to be 1 plus 0.025. So this becomes 100 times 1.025. And that's going to be raised to the 10th power. Now, once again, how did I do that? Well, 2.5 divided by 100. First of all, you could plug it into your calculator. Just be like, all right, it's 2.5 divided by 100, see what it becomes. Or you could realize that 2.5, like anything divided by 100, just moves the decimal place twice to the left. So it's like that. So it'd be 0.025. And when you add that to 1, it just becomes 1.025. Anyway, raising this to the 10th power and then multiplying it times 100 would give us, that would give us approximately 128. Okay, and really it's 128.01. So that's going to be 128.01, which is how much he has after 10 years, minus 121.90, which is how much Jessica has after 10 years. And that becomes, obviously I'll write it out, so it's like 128.01 minus 121.90, and that becomes $6.11. So that is the answer there, okay? Now, you do want to be careful with this. First of all, you need to know what you're doing when it comes to this formula. You need to recognize that R in Jessica's case is 2%, so it goes there, and then do all the calculations. You need to recognize that in Tyshawn's case, R is 2.5, and you need to follow the directions and so on. And so you need to do all of that, correctly, and really utilize this equation correctly. And but beyond that, you also need to round things correctly. Okay, so this was like, when I plugged this into my calculator, it became 121.899 something. Okay, so I turned that into dollars and cents, 121.90. Sorry about this, it kind of looks weird right now. Let me just I'll actually just move that over. So 121.90, right? That's what it rounded to. So I just rounded that right away. And this ended up being, really, it ended up becoming 128.008 something, and that rounds up to 128.01. So I rounded this one, I rounded that one, then I subtracted it, and I got 6.11. So that's important. The fact that they say round your answer to the nearest cent and ignore the dollar sign when gridding your response means you have to just ruthlessly round things off. One thing you could have done is you could have also taken the real number that the calculator gave you here and subtracted it from the real number that the calculator gave you here before you rounded it, and then you could have rounded the result, and you would get $6.11 as a result of that as well. Okay, so hopefully that makes sense. All right, so that is this video. It is the calculator section of, showcasing the kinds of problems that you might have to face on the SAT. And I hope it was helpful. And if you have any questions or comments, go ahead and ask or comment below. I do not think I made any careless mistakes. If you noticed anything, please let me know, and I will talk to you soon. Bye.